This short video will develop tree diagrams incorporating conditional and joint probabilities. Often, a simple table is not sufficient to describe complex conditional probabilities. Recall that a conditional probability is formed by a sequence of events, the probability of an event outcome given that another event has already occurred. Here is a problem from your text that can be set up using a two-way probability table, except the information is not provided in simple outcomes and probabilities. A football manufacturer delivers its entire production, including some defects, to an online retailer. The retailer conducts a quality test on each football, rejecting some defective footballs as well as some non-defectives. You are an analyst for UK Pro Limited, the manufacturer. You have several questions for the online retailer, but one question is paramount. What is the probability that any sampled football will be rejected by the retailer's quality test? First, identify the events in the problem. We have two, the manufacturer's production quality and the retailer's quality test. Each event has just two outcomes. The manufacturer ships either non-defective or defective footballs. The online retailer's quality test produces either an acceptable test pass or a reject due to test failure. There are just three probability values given in this problem. Let's state these probabilities in mathematical terms. 2% of footballs are defective. This is an outcome from one of our events. So we write the probability of a defective football equals 0.02. The second statement involves a sequence of events. A non-defective football being rejected by the retailer. This is a conditional probability. The probability of a quality test reject, given that the football is non-defective, equals 0.08. And another conditional probability. The probability of a correct quality test result, given that a defective football is tested, equals 0.95. The mathematical probability statements are a key step in constructing a correct probability tree. We must clearly define the conditional events and their associated probabilities before we can sketch a tree diagram. Now, let's jump to Excel and construct our tree. Conceptually, the tree is laid out with the initial or prior event outcomes first, followed by subsequent conditional events. There may be more than one conditional event. These are drawn sequentially to the right, adding depth to the tree. Here are the outcomes from our two events. Let's just add the last outcome. Now let's connect this node with a branch. Note that when we sketch our tree in this manner, we can arrange the boxes wherever needed and the branches flow with the tree. Event outcomes comprise the nodes of our tree, while each branch must have an associated probability value assigned. Probabilities in the first level of our tree are called prior probabilities. Values in subsequent levels are conditional probabilities. Follow the path through the tree associated with the conditional probability of 0.08. The tree describes this value as the probability of a quality test reject, given that a non-defective football is tested. In this problem, it's pretty easy to calculate probabilities for the other branches, since each event has only two outcomes. If we know the probability of a defect, the probability of being not defective is 100% minus the defect probability. Be sure that every branch has a probability. A joint probability is the probability of multiple events occurring. There is a joint probability associated with every path termination in the tree. Joint probabilities are calculated as the product of probabilities along each path. For example, the joint probability of not defective and test pass equals 0.98 times 0.92, or 0.902. Following each possible path through the tree, calculate the joint probability products. If you laid out your tree and calculated the joint probabilities correctly, they will sum to 100%. Now, we can finally answer the original problem question. The probability of failing the retailer's quality test is the sum of two paths: the probability of not defective and being rejected by the retailer, plus the probability of defective and being rejected by the retailer. This sum is 0.078 plus 0.019, which equals 0.097. So, the online retailer will reject 9.7% of all footballs it receives from UK Pro Limited. We have to wonder, if the manufacturer believes only 2% of its footballs are defective, why is the retailer rejecting 9.7% of them? It appears that the two companies' quality procedures are not in sync, and they are not testing the same attributes of each football. Substantial cost savings and less scrap would be realized if their quality testing were coordinated. This was a review of probability trees. Thank you.